Well, so currently you are the only one in the meeting.
Yeah. Yes,
So
sir. Happy
would
Sundays.
would you
Happy
like?
Deepavali, sir.
Okay, it is quite early, but okay. Happy Diwali to you. It's generally a festive season, so that's why I took break in the last two classes. But anyway, so do you want to continue?
Yes, sir. We'll continue.
Okay. So let us start. So the main concept for this week is the regression and testing of hypothesis. So okay, so let us first look at two problems from regression. Then we'll move on to the testing of hypothesis. Okay, so let us start. So this is the problem statement. Uh, this is the same problem that is given in the assignment itself. So there are two random variables x and y. Okay, and the two regression lines are given like this. So 2x plus y equal to 13. This is one line, and another one is 3x plus 2y equal to 21. So these are the two regression lines, but we do not know which of them is the regression line of x on y. Okay, so we are just given two regression lines, but we are not told which of them is the regression line of x on y and the reverse thing. So we will have to find out through calculations. So at the end of the day, we are asked to find an estimate of x whenever a value of y is given. So when y is 1, find an estimate of the random variable x. Okay. So to find this estimate, of course, we need to first find the regression line of x on y. So in this regression line, the values of y will be known, and we will find an estimate of x from the regression line of x on y. So we'll have to first identify which is the regression line of x on y. Okay, so that is what I have written here. So this is what we need to do, regression line of x on y. Now you know the properties of the two regression lines. So the point at which they intersect is the expectation value of both of the random variables, right? So the two regression lines.
Yes, sir.
Yes. So here the two regression lines intersect at x equal to 5 and y equal to 3, as you can easily see. So that means the expectation value of the random variable x is 5 and that of y is 3. Okay, so that much is fine. Now we have to identify the regression lines. Okay, so there is no hard and fast algorithm, so we have to start with an assumption. So there are only two lines. So let us first assume that 3x plus 2y equal to 21 be the regression line of x on y. So if we assume this to be true, then of course the second line, the remaining line, have to be the regression line of y on x, so vice versa. So these are the assumption. Now we will have to check whether this assumption is feasible or not. So if it is feasible, then our assumption is correct. If it is not, then the reverse will be correct. So now let us see how to check whether the assumption is right or wrong. Okay, so we have assumed that 3x plus 2y equal to 21 is the regression line of x on y. So what is the general form of regression line of x on y? So the general form is like that. So x minus ex is equal to regression coefficient, that is exy, multiplied by y minus ey. So this is the general form of the regression line of x on y. Okay, so since we have assumed the first line to be to satisfy this case, so let us first express this equation 3x plus 2y equal to 21 in the desired form. So we already know the expectation values, so using these, so this line can be expressed like this one. So this is the equation of the regression line of x on y under our assumption. Okay, so that means, so we can now extract the regression coefficient, and the formula for this is this one. So rho multiplied by standard deviation of x divided by standard deviation of y is the regression coefficient exy. Okay, and from this equation we see this is minus 2 by 3. So this is just slope of the regression line. So this is one thing, and the second thing is the second line. So under our assumption, the second line will be the regression line of y on x, and those lines have the general form like this. So y minus expectation value of y equal to eyx, so regression coefficient eyx multiplied by x minus expectation value of x. So that is the general form. So we have to express the equation in that form. So we can easily do that to find this is the regression equation of x of y on x under our assumption, and from this we can easily extract the regression coefficient eyx, and the formula for eyx is rho sigma y by sigma x, and from this equation this is minus 2, so just the slope of the straight line. So now under our assumption we have obtained these two equations. We have obtained these two equations involving the correlation coefficient, so which is rho, regression coefficient. So yeah, regression coefficient rho and standard deviation sigma x and sigma y. Okay, so if we multiply these two equations, you see, so in the left hand side you will get rho square, the two other factors cancel each other, and we are left with this rho square equal to 4 by 3. But we know that the regression coefficient rho have to be less than or equal to 1, right? This follows from Cauchy-Schwarz inequality as was done in the lecture.
Yes, sir.
Yes. So, but we have found under our assumption that rho square is 4 by 3. So that means here mod rho is greater than 1. So clearly this cannot be true. So since we have found mod rho greater than 1, so our original assumption was wrong. So we assumed that 2x plus y equal to 13 is the regression line of y on x. So this assumption is wrong. That means the converse must be true, because anyway there are only two lines. So So only two scenarios are possible. So that means the converse of our previous assumption is true. That means 2x plus y equal to 13 is the regression line of x on y. So these have to be the case. So now again we will express this equation in the appropriate form for the regression line of x on y. That means in this form. So this is the appropriate form, and we will extract the slope of this straight line and equate it like this. So this is one equation involving the regression coefficient sigma x and sigma y. This is one equation, and then clearly the remaining line have to be the regression line of x, regression line of y on x. Clearly, so again, so let us express this in the standard form, and this is this one, and from this extracting the slope we get another relation. So rho sigma y divided by sigma x is equal to minus 3 by 2. So just standard form for the regression lines. So we have got these two relations, and again we'll multiply these two equations with each other. So again, if we in the left hand side, sigma only rho square remains, the other two terms cancel each other, and in the right hand side we get 3 by 4. So the correct answer should be rho square is equal to 3 by 4. And so what will be the regression coefficient? So regression coefficient should be plus minus root 3 by 2. So one of the plus minus root 3 by 2 should be the answer. But you see, so let us look at this equation. So we know that the standard deviations are positive quantities. So, and the right hand side of this equation is a negative quantity, and in the left hand side we have rho and sigma x by sigma y. But sigma x by sigma y is a positive quantity because standard deviations are positive. That means rho have to be negative. So that is why we have to choose the negative root from this equation. So rho square is equal to 3 by 4. That means the regression coefficient will be rho is equal to minus root 3 by 2. So the minus sign comes from comparing this equation. Okay, so now we have found the regression coefficients. Okay, and so there was another option in the question. So since the regression coefficient rho is this one, and let us now put this root minus 3 by 2. So let us put the value of rho in this equation, and you will get after simplification this. So this is the relation between the standard deviation of x and y. So this was one of the options, and now after this by this time we have already found the regression line of x on y that will actually be needed to find an estimate of x when the value of y is given. Okay, so let us just substitute y equal to 1. So let us just substitute y equal to 1 in this equation, so which is the regression line of x on y, and whichever value of x you get, so that will give you an estimate of x when you know the value of y. So hence this final statement. So since this is the regression line of x on y, so when y equal to 1, an estimate of x is 6. So that is how you solve this kind of problems. So the tricky part is to find is to identify the regression lines correctly, and for that there is no algorithm, but you have to start with an assumption and you have to look whether the assumption is feasible or not. Like here we have started with an assumption and found that uh, the assumption leads to a result that is impossible. So it implies that the assumption we have started with must be wrong. So the converse have to be true. So it is that. So if you don't have any question, so let me move on to the second problem. Otherwise, please ask. Okay, so let us look at the second problem. So this is the problem that deals with real world data, and from this data we have to find the equation of the two regression lines and the correlation coefficients between the two random variables. So the data is of height versus weight for a random sample of 8 people. So heights are given in inches and weights are in kgs. That doesn't matter. So this is the table. So this is the table of height and weight, and we have to find the correlation coefficient between height and weight and the equation of the two regression lines. Okay, so how to tackle this kind of problems? So of course you know, to find the so correlation coefficient can be found very easily, of course. So you just have to calculate the expectation values of several variables, like so what is the equation of correlation coefficient? So this is this one.
So this expectation value, how did you came to 65.25?
Okay, I will explain. So let us first understand what do we actually need to find the correlation coefficients and the two regression lines. So this is the correlation coefficient and this is the formula for that. So covariance of H and W divided by standard deviation of H and standard deviation of W. So how to find these quantities in the numerator and denominators? So let us begin. So we have to find the standard deviation of H. So for that we first need to find the expectation value of H, and this is this. So of course, so you are given 8 data points and they have individual values, so you just sum them and divide them by 8. So that is how you get the mean, right? Simple formula.
Okay, sir. So it is mean.
Yes, it is mean. Just simple expectation.
Okay.
So it is the mean, and now if now that you have found the mean, so you know how to find the standard deviation, right?
Sir, please once tell how to for the standard deviation only. To get the standard deviation.
Yes, so standard deviation is, so the square of the standard deviation is variance, and variance is mean of H square, right, minus square of mean. That is the formula, right?
Okay, sir.
Okay, that is how you find it. So you, like for calculating the standard deviation in height, so what do you need to do? So just take like 65 square plus 62 square plus 60 square, add them up to plus 65 square in the last, and then divide them by 8. So that is how you get the expectation value of h square. And then you have to subtract from that the square of EH, and that will give you the square of the standard deviation. Okay, take the square root of the result of the subtraction and you will get the standard deviation, which is the square root of the variance. So that will give you this sigma h. And similarly, repeating this same procedure for weight, you will get these results. So EW is this and sigma W is this. Now that we have found the sigma h and sigma w, we also need to find the covariance between h and w, and the formula for covariance is this one. So expectation value of h w minus expectation value of h multiplied by expectation value of w. So can you tell me how do you find expectation value of HW?
Yes, sir. Expectation value of HW.
Sorry, I couldn't understand.
Sir, we will multiply each term and find the mean line.
Yes, you will multiply each of them, like 65 multiplied by 75.
Yes, 1 by 1 multiply and
yes.
Sum them, find them.
And divide them by 8. So then 62 multiplied by 70. So do this up to 65 multiplied by 64. So do this, add this and divide it by 8. That will give you EHW, and you already know EH and EW. If you calculate this, then you will get this result. So this is the covariance. So now that we have gathered all the tools to find the correlation coefficient, we just need to substitute the values that we have found, and you will get this answer. So the correlation coefficient is 0.73. So this is one of the options. So this is result. Okay. So now let us move on to find the regression lines. So the regression line. So let us first find the regression line of H on W. So regression line of H on W. So how do we do that? So this is the general, this is the standard form of the regression line of H on W. So in the left hand side you have H, and in the right hand side you have these terms involving W, and the coefficient is given by this. So this is the coefficient. So the slope of the regression line of H on W. So clearly you can, so of course we know the covariant of, so if we look at the slope, we know the numerator that we have just calculated, and for the denominator we have sigma W, and variance of W is just the square of sigma W. So if we just perform this, so we have gathered all the required values, and that will give the slope as 0.4586. So just simple, so just following the formula, nothing more. And you know EH is this one, 6525, and EW is this one. So just substitute that and take this on the other side, and you will get one of the regression lines. So that is the regression line of H on W. Okay. So this is the regression line of H on W. I think that in the assignment, So there is, the options are quite vague. So the options are like find regression line of x on y, but they have not specified what x and y are. Here I have chosen to write h and w instead. So the notation is quite clear, but you can see the resemblance between these answers and the ones that are given in the options. Think this is one of the options, but the problem is, so we are getting 32.4016. So I guess you have 32.4028 in the option. So I think we are close enough to mark that as an option. So, okay. So this is the approach, and whatever result you get, you get. So similarly, you find the regression line of W on H. Again, the standard formula. This is the formula. Okay, and the slope of the regression line will be given by this. So we know the numerator directly. So this is the numerator, and the denominator is var h, which is the square of standard deviation of h. So substitute these values, and you will get the coefficient. You will get the slope of the regression line of W on H as this one, and then perform the calculation, and you will get this line as the regression line of W on H. So again, this constant coefficient differs by a little from the one given in the option. Okay, so this is the answer. So as an illustration, how to use the regression lines. So one of the option is to find the most likely weight for a 6 feet height. So what will be the most likely weight for a 6 feet height? So 6 feet height. So which regression line should we use to find this?
Yes, yes.
So yeah, so for a given height, which regression line should we use to find the most likely weight? So it should be the regression line of weight on h, right? Because h is given and we have to find an estimate of w. So that means we have to use the regression line of w on h.
Yes, sir. Wait for 6 feet height. So wait for height. So
Yes.
wait on h.
Yes. So we have to use the weight on h, and that means we have to use this equation. We have to use this regression equation. Now just substitute the 6 feet. 6 feet means 72 inches. And you will get this result. So 79.5 kg, and that differs from the option. So the option is 84 kgs.
Sir, once I saw the chart, na, initial chart was there.
Yes.
Table 70. So, sir, where that value would lie in that table? Around 70.
No, let me. Well, someone. So what was the question? So that is the most likely value, but your real life data may differ. Okay, you are just making an estimate from the given values.
Okay, correct.
Yes, because you see, so only the EH and EW lies on the regression line, right? only EH and EW lies on the regression line, and no one of this particular data points lie on the regression lines. That is one thing. So only the expectation values lies on the regression line.
So sir, regression line is like expected line or what?
So you see, so regression line means, so okay, so you have 8 data points, right? So you have to find, ideally you should find a curve that pass through these 8 points.
Okay, yes sir.
Okay, so you know, so if you have two given points, so one straight line can pass through that, a unique straight line. So if you are given three fixed points, so only one circle can pass through that, a unique circle. So things like that. So you should ideally find a curve that passes through the 8 points. But instead of finding the complicated equation of the curve, we estimate the curve by the straight line. Sorry, we approximate the curve. We approximate the curve by a straight line such that the errors are minimum. So you see, I hope you have seen the derivation of the regression line, like how do you find these coefficients. So you start with an arbitrary line y equal to mx plus c, right? And then you find m and c by minimizing the errors, the expectation value of errors. So
yes sir.
Yeah, that is the derivation of the regression line. So this is the optimum line in the least square sense. That means the error. The square of the errors is least for the straight line. So you can think of many other straight lines, but for this particular straight line, the error from these data points will be actually the least one. So this is called the least square fitting by a straight line. So we should actually find a curve, but we are somehow too adamant to find that. So we are just being adamant to fit it as a straight line. So nothing more. So now that we have decided that we'll fit that as a straight line, we are just trying to find which straight line will be the best one to represent these data points. So nothing more. But none of these data points will actually lie on the straight line. So much with regression. So now let us move on to the next problem. So this is a different problem. So different concepts are involved. So let us first read out the problem statement. So certain tubes manufactured by a company have mean lifetime 800 hours and a standard deviation of 60 hours. So the large population of the tubes have the mean lifetime 800 hours and a standard deviation of 60 hours. Now we are drawing a random sample of 16 tubes. We are drawing a random sample of 16 tubes, and we have to find the probability that this random sample have the mean lifetime between these 790 hour and 810 hours, or in another case more than 820 hours. So given from a population of tubes of some given mean and standard deviation, we are drawing a random sample of 16 tubes, and we have to find the probability that the mean lifetime of the sample is uh, between some particular limits or more than some limit, etc. So this will involve the sampling distribution concepts. So that is the first line. So from an infinite population of tubes, we are drawing 16 tubes at random. Okay. So now we know from the property of sampling distribution that the mean of the sampling distribution of means must be what? The mean of the population, right? So this is one of the concepts. The mean of the sampling distribution. So please note this phrase, the mean mu x bar of the sampling distribution of means. So you know you are drawing a random sample. Yes, the mean of the sampling distribution of means must be equal to the mean of the population. So this is one of the properties of the sampling distribution. And now another property concerns with this standard deviation. So the standard deviation sigma x bar of the sampling distribution of means must be this, sigma by root n, right? So this is valid when the original population has infinite members. So here we have assumed that this is the case. Okay. So for our sampling distribution, the standard deviation will be this, sigma by root n, and that means it should be 15 hours. So mu x bar is 800 hours and sigma x bar is 15 hours. So this is just the property of sampling distribution.
Sir, I did not understand the question.
Okay, so which part is giving you problem?
So this random sample.
Random sample, okay. So so in the original population, so mean life is 800 hours and standard deviation is 60. So like you can also have from the infinite population, there may be a tube of say mean life, say a lifetime 740 hours. It can be, right? Because 800 plus minus sigma plus minus 2 sigma, all of them are in the population, right?
Yes, sir.
So the mean is 800 hours, but they are distributed according to a normal distribution. So you can definitely find a tube that has lifetime 740 hours, say, or 750 hours, or on the other side of the spectrum 860 hours. Okay, but the mean have to be 800 and standard deviation 60. So keeping that in mind, so what is the probability that the mean lifetime of the 16 tubes that you have drawn, okay, is between 790 and 810. So it could have been 800, it could have been 790, the mean lifetime of the 16 tubes that you have taken.
Yes, sir. Okay.
So yes. So the sampling distribution. So we have now find the sampling distribution, and we'll of course from the central limit theorem, you know, for the large number of variables, for the large number of population, the distributions may be approximated by a normal distribution. So we shall assume that the sampling distribution of means is the normal distribution. This is the assumption of central limit theorem. So we assume that the sampling distribution of means is the normal distribution, and this normal distribution will have mean 800 hours and standard deviation 15 hours. So if this is the normal distribution, so of course we definitely know the probability density. So this is the simple normal distribution probability density. This is quite familiar by now. So mu x bar is 800 and sigma x bar is 15. Now, given this probability density, we have to find the various probabilities. So that means we have to integrate within some specific regions of the values of the random variable x. So we are given this probability. So we have reduced the probability density for the sampling distribution to be this one, and now we have to find the probability that the mean lifetime x of the group is 790 to 810. So this mean lifetime x is the random variable actually. So mean lifetime is the random variable and its value is x, and that is the value taken by the random variable. So probability that x lies between 790 and 810 is what we need to find out. So how do we do that? So we are already given a distribution function. So this is the probability, right? We have already...
Yes, sir.
Yes. So integrating the probability density within a stipulated limit of the values of the random variable. So this is a continuous probability distribution. So do this, and then okay, so you tell me one thing. So is this step clear? So the one highlighted.
No, sir, there's 2 by 3. Minus 2 by 3 to 2 by 3.
Is it clear to you? So how it can be derived?
Not clear, sir.
Oh, no. Okay. Well, so you know the z values of a normal distribution, right? Like how to reduce some arbitrary normal distribution to the standard normal distribution that has mean 0 and standard deviation 1. So that involves the concept of the z value of the random variable in normal distribution. So using this that concept, you can do that, or also you can see. So if you substitute mu x bar is 800, right? So mu x bar is 800, and if you just do the change of variable in integration, so this is standard real integration techniques. So just do change of variables. So first substitute x to be x equal to x dash plus 800, change the limits accordingly. Okay. So if you substitute x equal to x dash plus 800, so you will get the limit as upper limit will be 10 and the lower limit will be minus 10. Okay.
Yes, sir.
Yes, and then you are left with e to the power minus x dash square divided by 2 sigma x bar square, right? And now you do x dash equal to sigma x bar z. Sigma x bar means it is 15. So that means you have to do x dash equal to 15z. So then the limit for z will be 10 by 15 and the lower limit will be minus 10 by 15. And that is how you get 2 by 3 and minus 2 by 3. And accordingly, the sigma x bar square in the outside gets cancelled when you do the change of variable x dash equal to 6 sigma x bar uh, z. So this is the change of variable technique. Or otherwise, it is a standard stuff to do in the theory of normal distribution. Just find the z values and do that. So, so in essence, this integral can be reduced in this form. And how do you find the value of this integral? So there is no other way, but you have to use that table. So I hope you have seen the normal distribution table. So there are tabulated values. So you just have to use those values from here accordingly. So use the value and you will get this one as the answer, 4950. And for the second case, you have to find the probability that the mean life x of the group is greater than 820 hours. So that means we have to find the probability when the random variable takes value greater than 820. So we are already given the probability density and then we have to just integrate this. So up to 820 to infinity. Again, do the change of variable. Do the change of variable of the integration. Do the change of variable of the integration and you will get this 4 by 3 up to infinity. Use the table and you will get 0.0912. So was it clear?
Yes, sir. Good workout.
Okay. Yes, sir. Just do this change of variables. I mean, express that in the standard normal distribution form and then use those values from the Gaussian integration tables. So that is what you have to do. Now let us do some problems from this hypothesis testing. So hypothesis testing. So I hope you are familiar with that. So what do we need to do? Like we assume some hypothesis and rule that out or accept that in some significance level. Okay, let us go through the problem. So this is the statement. So it has been found from experience that the mean breaking strength of a particular brand of thread is 9.72 Newton with standard deviation 1.40 Newton. So this is for the infinite population of that threads. So the mean strength is 9.72 Newton and standard deviation is 1.4 Newton. Now we have drawn a sample of 36 pieces. So Recently, a sample of 36 pieces of thread showed a mean breaking strength of 8.93 Newton. So we have drawn a sample of 36 pieces and found that the mean breaking strength of that sample is 8.93 Newton. So of course you may think that the quality of thread has degraded, right? So
Yes, sir.
earlier it seemed like 9.72, but you have drawn 36 threads and you found that to be 8.93. Now you are claiming that the thread has become inferior. You are claiming. Now you have to test your claim at a significance level of 0.05. That means, uh, can you claim this uh, when you are 95% confident? Like, can you, from this observation, can you claim?
No, sir. Those because that sample is not random sample now. Maybe they are biased sample taking.
No, that's a random sample. That is a trick. So
Okay.
that is
Okay, if it's a random sample, yeah, we can say it is of inferior, no? Because 8.93,
95%.
significance level of means what? Significance level of 0.02?
So, okay, so are you familiar with the theory? So the last lectures, the hypothesis testing.
No, sir.
Well, then it's a problem. Mm, okay, let me see how I can proceed.
Sir, you can proceed, sir. I will get from the.
Hmm?
Sir, you can proceed, sir. I will understand on the way.
No worries. Okay. So, oh, do you know null hypothesis?
Null hypothesis, sir.
So you have to make a hypothesis and you have to test whether that is correct or not. So in the question you were asked, so to test the claim that the thread has become inferior at a significance level of 0.05. So, but a null hypothesis is a particular statement, like a very definite statement. So it is a statement of equality. Like here you can, so to test whether the thread has become inferior, so your you can choose to test that the mean breaking strength is less than 9.72 Newton, right? So if you can test it to be less than 9.72 Newton, then you can conclude that it has become inferior. So the so let us make a null hypothesis that the mean breaking strength is 9.72 Newton. So the original mean that is claimed by the brand, the manufacturer. So let the null hypothesis be this one. The mean breaking strength is 9.72 Newton, which is mu naught. And let the alternative hypothesis be the mean breaking strength is mu1 less than 9.72 Newton. So this is the alternate hypothesis. So depending on the confidence level and Z values, we shall accept or reject the null hypothesis. Okay. So if we reject the null hypothesis uh, in favor of this alternative hypothesis, that means we claim that the thread has become inferior. See, do you understand the logic first? I mean, just the language.
Oh, yes, sir. Yes, I got the logic.
Yes. If we reject the null hypothesis in favor of the alternate hypothesis, that means that we support the claim that the thread has become inferior. So there is something called one-tail test. So you see your alternate hypothesis is actually an inequality. So mu1 is less than 9.72. So that is a left inequality. So in these cases we use the left one-tailed test. Okay. And all of these things have to do with the standard, with the normal distributions. So the z value of the sample is this one. So the sample you have drawn, the z value for this x bar is this. So x bar minus mu naught sigma by root n. So sigma by root n, it is the standard deviation of the sampling distribution. So as we have also seen earlier. So this is z, and for this left one-tailed test, the critical value of z is this. So you will be given a table, and from that table you have to read off these critical values for some particular significance level. So for this significance level 0.05, the critical value is this. So minus 1.645, and we thus see that so the z calculated lies in the critical region, because the z calculated is less than this critical value of the left one-tailed test. And since z calculated lies in the critical region, that means h0 should be rejected. So we reject h0. That means the alternative hypothesis should be supported, and that means we support the claim in the significance level 0.05. Well, so but in a defined significance level, suppose had we been given like 0.001, the final result may have been defined, because the critical value for alpha equal to 0.001 may have been defined. So of course it will be defined, but it may have been less than this calculated value of minus 3.3. So you can only claim at a particular significance level. So that is why the significance level is important.
Sir, once a previous question at last line.
Yes.
So sir, claim should be supported. It is inferior, that thread.
Yes. So you see, so h0 should be rejected. So what was h0? h0 was this. h0 should be rejected in favor of the alternative hypothesis H1. And what is our alternative hypothesis? So our alternative hypothesis is this. So we reject H naught to support the alternative hypothesis, right? And
Sir, there can't be any another alternative hypothesis, no? There cannot be another, no? It will be this only. Region, okay, sir.
So see, in the problem, so you have to find whether the thread has become inferior or not. So you have to choose your alternative hypothesis accordingly. So inferior, so how do you test whether it has become inferior or not? So
sir, in the lesser force, if it gets a break, no, then it is inferior.
Yes, so that is why I have made this alternative hypothesis.
Yeah. Yes, we have taken UN lesser than 9.17.
Yes.
Correct.
Yes, that is why. So there may have been another claim that
that it has become superior then.
Okay, you may have claimed that, but you see, then you would have supported the null hypothesis. If you took the alternative hypothesis like mu1 greater than 9.72, okay, then after doing this calculation, so that would have involved right test. So right one-tailed test. That would have involved a right one-tailed test, and for the right one-tailed test, the critical value of Z would be plus 1.645. Plus 1.645, but the Z value which you have find is the minus 3.386. So that means the Z value that you have find does not lie in the critical region of the right one-tailed test. Here it lies in the critical region of the left one-tailed test. That is why we are rejecting the null hypothesis. Had you used the alternative hypothesis like mu1 greater than 9.72, then Z calculated would not lie in the critical region of the right one-tailed test that you have had to use there. So that means in that case you would support H naught. Okay. So
yes, sir.
Had you made the alternative hypothesis mu1 greater than 9.72, you would then support, so you then would not reject H naught. So then you would reject the alternative hypothesis itself. So that will give you no advantage to test this claim. So you have to choose your hypothesis accordingly. So accordingly what you have been asked to test. Similarly, you could have taken that alternative hypothesis that the mean strength is not equal to 9.72. It could have been either greater than or less than, you don't care, but you care only about the inequality of it from 9.72. That will also do not give you any advantage to claim that whether the thread has become inferior or not. Only this hypothesis will give you the advantage. So we will have to choose accordingly. So did you understand the logic?
Yes, sir. Yes, I got.
Okay. So this is okay. Let me discuss this one. So since you have understood, so let us do this question. So the percentage of A's given in a course over a long period of time was 10%. So the only 10% of students got an A. over a long history of this course. Now, during a particular term, there was 40 A's in the group of 300 students. Now, test the significance of this result at a significance level of 0.01 using a one-tailed test.
Sir, over a long time and during a particular term.
Yes.
These are two different, now.
Yes. That is a this is a full stop. That is the history of the course. So it has been going on for a very long time, and 10% of the students have got A. But during a particular semester, a group of 300 students, out of a 300 students, 40 got A. So the group may consist brilliant students, who knows. So,
sir, but this is only one term, na?
Yes.
It should be consistent for the long course, long time.
Okay, so test the significance of this result. So you have to tell whether this result is significant for the long time or not.
Yeah, it is. Ideally, 10% means for 300, it should have been a 30, but it is 48.
Yes.
So it is significant, but it is for only one particular term, no?
That is how you do, like you draw a sample. So you are drawing a random sample of 300 students, out of which 40 got A. So you are drawing a sample, particular sample.
Yes, sir.
So significance means whether this result is significantly different from what is expected. Like expected is 10%. So is this result significantly different at a significance level 0.01?
Yes, sir, it is more than, no? More. It is more than 30. Ideally, it should have been 30, but it is 48. So it is significant. We will calculate.
At given level. So you have to again go through the calculation, previous kind of calculations. So it will really depend on this significance level. So 0.01 gives you one kind of answer. So 0.001 will give you another kind of answer. So like you will be saying with 99% confidence level that this result is significantly different or not. But then you may be asked to tell with 99.99% confidence level whether this is significantly different or not. So that may differ from the conclusion at 99% confidence level. So the thing to do is to this calculation. So the mean percentage is mu equal to 10, the mean of the population. And standard deviation was not given. So there is one option in the assignment that data is insufficient. But here we see that, so you see there the standard deviation is not given. In the previous problem, the standard deviation was given. Here the standard deviation was not given, so you may think that the data is insufficient. But I will show you that that is not the case. So let the standard deviation in percentage be sigma, and now you see, so the percent have to be greater than 0, right? It cannot be negative.
Yes, sir.
So that means mu minus sigma must be greater than 0. So this one. So mu minus sigma must be greater than equal to 0. So the standard deviation, the error, so it must be greater than equal to 0. That is, a percentage in the sample can be negative, and that means the sigma can only lie between 0 and 10. So sigma cannot be greater than 10. Of course it will be less than 10, but we are not given, and we can only infer that it cannot be greater than 10. So this is the bound on sigma. Now in that particular term, we found that this x bar is 40/3%. So significance. So to test the significance, what do? Again we do a null hypothesis. So here our null hypothesis is h naught, that is mu equal to 10, and our alternative hypothesis will be, okay, so why will we choose mu greater than 10 here? Because you see, so our x bar is greater than 10. So in this particular sample, x bar is greater than mu, and so it will be beneficial for us to choose the alternative hypothesis as this. So as mu greater than 10. And we are also asked to use the a one-tailed test. So that means we cannot do the alternative hypothesis as an mu not equal to 10 kind of statement. So it has to be a greater than or less than kind of alternative hypothesis. And since the sample, in the sample we see that x bar is greater than 10, so we'll see that it will be beneficial to choose the alternative hypothesis as mu greater than 10. And in the question we are asked to use the one-tailed test, and when this is the case, mu greater than 10, so we can use the right one-tailed test. So again, so z calculated here. So z calculated here is this. We do not know sigma. So this is 100 by sigma root 3. And clearly, since sigma is less than equal to 10, and that means this z cal, so the calculated for our sample, the z value of x bar calculated for a sample have to be greater than or equal to 5.774, because sigma is less than equal to 10. Now the right one-tailed test at a significance level at alpha equal to 0.01 has the critical value 2.33. So again, this can be found from the table. This is the critical value 2.33, and now z cal is greater than 2.33. So 2.33 is less than the minimum value of z cal. So definitely z cal must be greater than 2.33, and that means z cal lies in the critical region of this right one-tailed test at this significance level alpha is equal to 0.01. And since z cal lies in the critical region, that means h naught has to be rejected. And if z cal lies in the critical region, so that implies that the result is significant. So this is the standard language for this kind of problems. So h naught is rejected is equivalent to that the result is significant. So whenever the result is significant, so you reject your null hypothesis. So like the result is significantly different from what you have hypothesized. So significant means the result is significantly different from our expectation at a particular level. So that's that. That is how you solve this kind of problems. The main thing is to choose the hypothesis appropriately, like the one that will be compatible with the hypothesis that is given in the question. Okay. So now, okay, so I'll suggest you to go through the lectures and then come back again to understand this.
Yes, sir.
Okay. So let us end this session. So are you enrolling for examination or not?
Yes, sir. I will write exam now.
Okay. So it is on the 30th. Okay. Another thing. So are you able to see the files in the what is Google Drive? So
Sir, I haven't checked it recently.
okay, so you can, I mean, you are able to find the files in the Google Drive. Okay, you have the link, right?
Sir, pata nahi, sir. For a long time, I haven't checked with the drives.
Okay, so no, you should have the link actually. Okay. So it will be put there and you can come back later when you have understood the theory. Okay, then I will end this session.
Sir, question 5th.
Question 5th. Okay, I say that you first understand the theory, then I think you will be able to do it yourself.
Sir. Okay, sir. It is same as now.
Yes, it is almost same. This is almost same, so nothing difficult. So it can be tackled like these two previous problems.
Okay. The claim, equivalent claim is 5% of the goods.
Okay, so let me go through this. So the manufacturer claimed that at least 95% of goods he sells is functioning. So at least 95%. So that means at most 5% is faulty, right? So now an examination of a sample of 200 pieces of goods revealed that 18 were faulty. So he says that at most 5% is faulty, but the examination shows that out of 200, 18 were faulty. That means 9% were faulty. Now,
yes, so 9% fault.
Yes. So test is claimed at a significance level of 0.01.
So this mu plus sigma there between 0 to 5 for standard deviation.
Yes, so because you see, so mu is not given, right? He says that at most 5% can be faulty.
So mu is not known.
Yeah, we do not know mu, we do not know sigma. But he says that at most 5%. So that means, so when we do the error in the physical experiments, so this is mean plus standard deviation. So we write that as mu plus minus sigma, right? We do the
yes, sir.
Yes. So from that consideration, I have written that. So mu plus sigma. So after accounting for these errors, So that must be less than or equal to 5, because he claims that at most 5% is faulty. Okay, so he claims that at most 5% is faulty. So that means it is in our language is that mu plus sigma less than 5. And let us take the null hypothesis as this: mu plus sigma is equal to 5, so that we can make the alternative hypothesis that mu plus sigma is greater than 5. So we want to find the alternative hypothesis that mu plus sigma is greater than 5. Uh, that is more than 5% of his goods are faulty. That is our alternative hypothesis. So for that we yes. So a null hypothesis have to be a definite statement. Like it cannot be more than, less than, not equal to. It have to be a strict statement like equal to something. So we want to test. We want to actually look into the alternative hypothesis that the faulty goods are more than 5%. So it is beneficial to take a null hypothesis like mu plus sigma is 5. So now test this whether this null hypothesis can be accepted in this given significance level, and we'll see and calculate this ZCal, and you will find that ZCal is greater than 14. ZCal is greater than 14, and now okay. So the alternative statement is a right inequality. So mu plus sigma is greater than something. So we use the right one-tailed test. Okay, and for the right one-tailed test at at significance level alpha equal to 0.01, the critical value is 2.33. The critical value is 2.33. That means the calculated value of Z is already greater than the critical value of the right one-tailed test. That means the calculated value of Z lies in the critical region of this right one-tailed test, and since this lies in the critical region, that means the null hypothesis have to be rejected. Since it lies in the critical region, the null hypothesis is rejected. So what is our null hypothesis? So null hypothesis is mu plus sigma equal to 5. So we reject the null hypothesis in favor of the alternate hypothesis. And our alternate hypothesis is that more than 5% of his goods are faulty.
So, sir, more than 5% of goods is faulty. This should be the correct.
So this should be this should be favorable over his claim that less than 5% is faulty. Yes.
Okay. So, sir, here alternate hypothesis is correct.
Yes. In favor of the null hypothesis. So you have to compare actually. So the null hypothesis is more incorrect here. The alternative hypothesis has more chance to be correct here. So you can say with 99% confidence that he is wrong.
So this 99% from where you find whether it is 95% confidence level?
Okay. So this is 0.01 means, so 1 minus.
Okay, if it is 0.05 it is 95%.
Yes.
Okay. And sir, I haven't enrolled for this examination in NPTEL, so I am studying for maths for civil services mains examination.
Okay.
So I am doing maths for that, sir.
Okay. Well, good luck for the exam then.
Yes, sir.
So I guess this is the last session. So I missed two sessions, but I plan to give these solutions in the Google Drive. So if you have the link, you can find those.
So your mail ID is there, no?
Okay. Okay, I'm writing it in chat box.
Sir, if I post there some query or problem solution, you do reply.
Yes, I will reply. So have you found?
I got, sir.
Okay.
So
Okay then, feel free to ping anytime with your doubts and queries. But I'll suggest you to first go through these lectures. I mean, this hypothesis testing a little different from what you have done till now. So
yes, sir.
yes. Okay then, in this session.
Okay, sir.
Bye.
Happy Diwali and thank you, sir.
Okay. Yes. Good luck for your exam and happy holidays.